Thank you, Per-Olof, for that presentation and introduction to the technology needed for autonomous driving. You'll be back in about 10 minutes for our panel discussion. So while now introduced to some of the technology needed to detect objects surrounding the car, we'll now dig deeper into this subject. So we welcome Gapwaves and CEO Lars-Inge Sjöqvist.
Thank you very much. I'm happy to be here at Redeye. Not the first time, and I hope not the last one. It's a pleasure to be back and show a little bit more physically as well, because I have been working over the Teams long time now, I think. So it's time to have real meetings again as well. Yeah, Lars-Inge Sjöqvist is my name, and I am the CEO of Gapwaves. So I will make a short update on where we are. The company is started, as I told before, 2011 by Professor Per-Simon Kildal. And today we have around 8,000 shareholders, and there is a market cap in the company of 150 million euros. We have patented technology, and that is something we are growing all the time, so it becomes more and more. Today it's over 30 different patent families we have in our portfolio. This is important to not be too easy to copy, so to say. And we are specialized in antennas. I show some pieces here later, but it's also important to say that we work mostly in the area of automotive, but also in telecom. But it seems that automotive is taking this into the technology into their products quicker, I must say. And today we are 30 people plus working in our office in Gothenburg, just south Gothenburg, a nice place called Liseberg. So it's easy to find us now. I will make a short video here about the technologies. Everyone can look at that.
The industry is looking into waveguide antenna technology, basically a metallic rectangular tube in two halves through which radio waves can travel with low losses. The electrical and magnetic fields from the wave induces electric current along the walls of the waveguide, resulting in high requirement on tolerances to avoid power and efficiency loss. Gapwaves replaces the method of using metallic walls with a metamaterial surface called an artificial magnetic conductor. A unique structured surface consisting of pins has the similar effect to a perfectly sealed wall, completely preventing the waves from propagating in undesired directions without even having to have contact around the waveguide. This allows for an effective waveguide to be built with dramatically relaxed tolerances, meaning it can utilize existing manufacturing technologies. 5G and autonomous driving are run on antennas. We hold the key.
Yeah, and that's what we still are saying. We hold the key. And quickly look into this frequency used today in different areas. Most of the communication is still on quite low frequencies. We are up in 3.3 gigahertz mostly. Also for 5G has been more and more common. We thought it should be up in 28 for the 5G millimeter wave, and that will come, but it still takes a little bit longer time. But the 77 gigahertz is a frequency used for autonomous cars or for radars. And this is also meaning that if you go up in frequencies, it becomes more and more difficult really to use your classical patch antennas, and you are interested into waveguide solution, which is what we do have. And this is very clear today that all the car manufacturers and also the tier ones in that area really are looking for waveguide solutions today. And that's our luck, I can say. So we are doing design work. We have also customers only buying, as we say, a license and can use our technology, but most of them also want us to produce and design antennas for their radar solutions. And we work also in some new verticals. In these cases, we are on what we call last mile delivery robots, etc. And this is new techniques. It could be also drones, etc. We are into that. We want to have a good radar solution for for the eye of, for example, a drone. And the last one, 5G, is also going on, but it's not in the same phase as we see the other ones at the moment. The radars in these cars, so to say, we are talking a lot of these different levels of, if you say, self-driving functionality. Yeah, there are many views on this one, but we can see the number of radars are growing dramatically in the cars, what we see coming up in the coming years. Maybe it's only one in total today, but we will see up to 5 and even more if you come to the full level 4 and 5. So for us, more radars mean more antennas, so it's a good sign for our future as well. And I would say most of them will be equipped with a waveguide solution over time. So the waveguide solution means that you can really broaden the view. We typically can have a view of 70 plus minus degree looking from one radar. This is more than what you can do today. Less, I would say more than 70% more. And you can also have the same time the range up to maybe 200 meters for a typical corner radar to find an object like one person on 200 meter distance. That has not been possible before. So we know with this performance we can deliver into the radar. It's really interesting for the car manufacturers and also for the tier ones doing these radars to use this technique. That's absolutely clear. And that means also higher resolution, of course. We are also touched into another technology which is called LiDAR. We are not doing any LiDARs, but we have often the question, what can you do in comparison with a LiDAR? And in this case, an imaging radar could be looking like this. It is a 28TX-RX version of an antenna, which is an imaging radar, and how that can see objects in the same way as a LiDAR. If you compare these two pictures, which is coming from a company called NXP, you can quite easily see that we are very close now to what you can have as a resolution from a radar echo as well as a LiDAR. This is, I think, also important to have in mind looking what is the possibilities for us and for the companies working with radars. Some word about the market and the brand. Gapwaves brand is really today known by the most important customers working in the radar segment. That's very nice for us because people talk about waveguides, they talk about Gapwaves, and that's very interesting. And some of them have already decided to go with us. Veoneer is one quite early. Hella, the last one now, was also deciding to go with us in a quite interesting combo of also buying a part of the company. And we do have a number of more tier ones which are not disclosed at this stage. They don't want us to tell the market who they are, but you can see them on the slide here on the left side. So I feel very confident that we will see our technique coming into the market dramatically over time, but it, as always in automotive, it takes some years before we are out there. They need to test a lot. And in the area of new verticals, we also see typically here companies like Amazon. Uber is also a company working with traffic, but in taxis, etc. Under is working with us, as you know already. These are companies going into other areas like last mile delivery. They could be drones, traffic management. This is a piece of work for the company Smart Micro. They are doing what they call traffic management solutions for smart cities, road, so you can see junctions, etc., from a radar perspective. And the good thing having a radar instead of LiDAR or camera is that you don't really have any problem with the weather conditions when it's foggy, rainy, or snowing. You can see still the echo coming out there. So this is one of the most important part to know about radar, I can say. And with a good antenna from us, you can have a lot more information from that radar. So the sensor will become more valuable, so to say. Some breakthroughs for us. Yeah, I mentioned Hella. They went into us as also as an investor. They do have a part of what we call an exclusivity in their agreement for corner radars. That means we will not run with corner radars or develop corner radars for someone else during a period until 2026. That is the agreement. But they also invested 182 million in Gapwaves, and of course that's also important for us to really have the time now to deliver and do what we need for the production, etc. These kind of pieces for under, we have made today 12,000 pieces of 77 gigahertz antennas, and they are delivered and are working for some different prototypes, works in mostly in US at the moment. And I think it's quite interesting that we do them by a supplier in China, but we also assembly and also test them in Gothenburg. So it's very much happening in Gothenburg on this area as well. I think it's time to end up here. And the reason to invest in our company is, of course, that we are working directly with very interesting big companies, global companies, and we are very much into what we call a mega trend on these autonomous vehicles. That's the most important part. Okay?
Thank you, Lars-Inge, for that presentation. We now move directly into the panel discussion for autonomous driving. So, if we start with you, how do you think the self-driving trend will play out? For example, is there still a case for level 3 cars, or will there be like a jump from level 2 to level 4? Could you just elaborate on your thoughts?
This is typically something we can elaborate or guess around, but I would say that it will take some time, whatever we do, and I guess that will be up in like in level 3. We will see like 68 to 70% on the market 2025 first. And what happened during that time, it has been changing quite a lot, what I've seen when we started. So I don't really have a guess. What is the level 1, 2, 3, 4, 5, 6? You can continue. This is like everything developing. You don't know the result yet.
Yes. What do you have to say about that question about how the self-driving trend will play out, Rebecca and Patrick from Klimato?
Yeah, I think I completely agree with Lars there. I mean, it's difficult with the different levels to define them. And I think the interesting for me is not level 3 or if it's level 4 or 5. The interesting to me is how fast the operational design domain actually can expand and grow from the very limited condition that there are today. But I think to reach level 4, there's definitely going to be a mix of level 3 and level 2 in order to collect data and to make sure that it is actually safe. And when proven safe, I think that's when sort of level 3 can actually go to level 4.
Yeah, and what do you see as the main hurdles for the advancement of autonomous vehicles, like progressing and being accepted to be on the roads? Per-Ola from Terranet, would you start?
Yeah, first of all, I think what is said before, I mean, it requires disruption to get to level 5, and disruption never comes along a linear sort of curve. So it has to sort of either come tomorrow or in 10 years, but it's a gradual process. And I think it's important to understand that EV comes first, because autonomous driving, the precondition for autonomous driving or high level of ADAS is that you have electromagnetic and electrostatic steering. So I think that is in a way a hurdle that first you really need to push out the electrical vehicles to the market.
Do you agree on that, Rebecca and Patrick from Klimato, that it like EVs need to come first and then autonomous vehicles can happen?
I think they will. I mean, the development is parallel, right? But I think again, the safety case and the scalability, that's the hurdle, and making sure that the system can actually handle the sort of real world conditions that I speak about previously. But there's definitely, I mean, the EVs, they're trending now, and they are a must, of course, but I think that they will be developed parallel.
Thanks.
I can ask
Yeah.
comment. I think absolutely it will develop very much in parallel as well, because I don't think there will be any stopping. We really are asking for ourselves to make the traffic more safe. So it's important really to have better equipment for it as well. We are in the hardware business in this case, but if you have a better sensor, you will have a possibility to make an even better situation and save some life. So it will go in parallel with the autonomous driving, I would say. I don't think it's only by EV, no.
If we look at one of the technologies that sort of needs to be in place for this also to work is the sort of connectivity and the network sort of capacities. 5G is sort of getting more and more adopted. How far along are we in that sense in terms of connection of the cars? Lars-Inge, you want to start?
I can start. As we see cars connected today, you are connected by 4G in the best case, mostly in 3G, I would say, and it's not a good weight at all. If you talk about what we saw from Terranet, having a shorter distance to do the braking, you can never use anything on the telecom side today. It's out of order. You absolutely need up in a lot. The latency must be on a millisecond or better, and that's far away. We are on 30 milliseconds today, so it can't work. If you are on the safety system, that's absolutely impossible.
Patrick, you were going to say something?
Yeah, if I may comment, I come from Ericsson in the past, and we kind of talked about these self-driving vehicles for a long time. But at all times, we talked about we need to have 5G. And it's a prerequisite to have 5G.
Yeah.
And we talked about that for years. And that is happening as we speak. So I would say the technology is actually there, but it needs to be utilized and leveraged upon. But I really think it is starting to take off. And companies like Ericsson, which traditionally is not in this space, they are extremely interested to be in this space because it's a data business, really.
I expect you concur, Per-Olof, or do you have anything you'd like to add to that?
No, I think I agree. I'm an ex-Ericsson guy too, but that was a very long time ago. But I think Sweden is extremely well set up when it comes to network efficiency, 5G deployment, and so on. So is China. So I think we should really have a watch looking east here. They have a good deployment, high network efficiency, also many test beds and launch pads for autonomous ADAS systems. So
I completely agree.
Yeah, if we stay on the topic of the Nordics or Sweden in specifics, we have a very strong automotive heritage, as probably everybody knows. And how is it coming from your relatively small companies trying to succeed against major automotive players or some perhaps some third parties in between? How is that trying to sort of break through the noise? You partnered with Hellas, I guess that's one way.
Yeah.
How is it to sort of be a
but the way to take new technology as we are coming from in this case is really to get into this big organization, and they should adapt our technique and make it happen in the cars, etc. It's too big step to go directly for us to the market. Of course, we need to have these kind of tier ones really adapting our technique, and that's what we are doing at the moment very well. It's very clear that Hella is there, Veoneer is there, I know that very well, and we have like 3-4 of them more to come here soon. So that's the way we can see it happen. Yep. And
Rebecca, Patrick, your go-to-market strategy?
I was just thinking about in terms of the perception of Sweden and Sweden as a car manufacturer. I think we are lucky enough to be in Sweden. We are lucky enough to have founded the company in Sweden because I think the trustworthiness of a company in Sweden talking about safety is worthwhile discussing. So in that sense, I think it's a good thing to be a company focusing on safety based in Sweden, perception-wise. So I think it's prerequisite and also an USP for all of us here.
Yeah, and I also think, I mean, the question sort of how do we get through? How do we reach these sort of massive players? And for us at Klimator, yes, we're very small, but we are pure play, like Patrick spoke before, road climatology, extremely niche, and we have the research, and we've been developing for the past 30 years. And for us to be able to sort of pinpoint to OEMs and tier ones that this will in fact be an obstacle in the future for AD deployment, and we have a solution, and we want to be able to provide the competence for you to build those systems adapted to it. So we work a lot with competence exchange, so partnering up and actually sharing a lot of information, and it's going to take time. I think that's sort of the general understanding of the automotive industry. I mean, it's all about thick skin, patience, having great technology and sort of competence, which is above all, and patience. So for us, the key is that we're pure play company and that we actually exchange competence with the OEMs and tier ones.
And also just to extend to that, I think in this elaborate way of working, I think a competition will be key moving on. We cannot just close our products and APIs and stuff like that. We need to have cooperation with competition as well as other players. So competition, I think that would be a key word moving forward in this elaborate way of working.
Great. And how do you think, like, we spoke about the necessity of 5G rollout before this rollout of autonomous cars can really happen. Do you see any other technological advancement that needs to happen before an actual deployment can happen? Would you start?
Maybe I'm a little bit pessimistic about and not so clear that 5G is still enough for the car manufacturers, because there is also part of the car which needs to communicate with the system. And vehicle to X, if I look at that currently, what is happening on the car manufacturer side, I'm not seeing that we really are in that move that we can say that we can use this 5G system, even if they were applied, as you say, from former Ericsson's guy here. But that's my view, that it's still quite a big gap. So for the car as such to really communicate a good way.
And what technology for the car will need to be in place for that to really occur?
We know, for example, that the antenna part of a car in communication is quite bad. A very bad solution to put something on a box of metal and make an antenna from that is quite difficult. So we start with a bad object. It's much easier to put an antenna on a person with a telephone than doing it on a car. Just one part of it, I can say.
What about what do you say, Per-Olof from Terranat? What technology is needed, and how much will 5G help?
Well, 5G or not, but I think it's all about safety. It's all about road safety, and we have something that no one else has. A sharp laser technology that can actually save lives on short distances, and I think that's key. As I said it before, I think EV is a precondition to achieve level 5, but there is a gradual evolvement until you reach level 5. But I think it's all about safety, because there is no one in the future that will just accept deaths at road or severe accidents. So I think what we focus on is something key here. That's safety, collision warning, and collision prevention. And I think you will see more of that.
Yeah, definitely, and I completely agree. But apart from sort of the 5G, other technologies, I mean, the vehicles and the system will have to have much more powerful and efficient compute systems, better existing sensors, and also completely new sensors. There will be new type of data streams, for example, the road weather data that we're speaking about. And I mean, there are some fantastic competence out there and some really cool startups that will start to sort of integrate themselves into this industry. And I think we'll see a lot new technology.
Yeah. And Per-Olof at Terranet, you spoke a little bit about level 5 automation. What are your thoughts on this? How long will it take? And I mean, what hurdles need to be overcome?
I think I said it in the beginning. I don't think there's not a linear curve, because disruption just happens for some reason. The black swan appears on the road, and then all of a sudden everyone goes autonomous. Hard to say, but I think a gradual development is certainly needed, because there is so much data points that you need to add into this sort of the complex traffic infrastructure, that it has to just go step by step. And again, there is no chance for a level 5 to happen without full deployment of EVs, because yes, you can build an AD or AV on a combustion engineering vehicle, but you definitely need electrical vehicles. So hard to say. 25 years, maybe 30 years, maybe 10 years. It's impossible, but
let's hope for the sooner from a consumer perspective. If we switch to the other side of things, that is regulations and what's happening from that point of view, we are quite a far away, at least in some countries or some regions, for autonomous driving to be both accepted and regulatory in place. How do you work, or do you work with those types of regulation issues, or is that more of well, let's say tier 1 issue? You want to start, Lars?
Yeah, we don't directly work with this kind of organization, but we see and we read and follow what's happening. As you said, very much is about making things safer and safer. And so far, very much of a car's development is about making the car safer as such. And then you use, like what we are working with, radars or cameras or other kind of sensors to get more information, because the car itself should take care of the problem, and not you as a driver, because we are quite bad in that sense. So the sensor technique together with the car, I think, is what is happening at the moment. And this full autonomous vehicle driving around everywhere, it will take some years, yes. That I will agree on.
Rebecca and Patrick?
I mean, we're not in direct contact with these sort of larger organizations. We're, of course, speaking to sort of umbrella organizations about the safety aspects that need to be taken into consideration. And there are a lot of accidents, for example, that are due to slipperiness or severe road surfaces. And we are basically speaking to Euro NCAP, for example, to include predictive and detective road weather systems to their roadmap, because we believe our technology can prevent and eliminate some of those collisions. So again, competence exchange within the area that we are in is what we do and try to sort of affect the roadmap ahead.
Yes. And where would you say that, like this type of technology, for this to roll out in new regions, it must come from the safety standard organizations, like mandating technology in order for it to roll out. So where do you see this happening? Will it happen in Europe first, or the United States? What are your thoughts? If Klimato, would you like to be first?
I mean, well, yeah, you go.
No, I was just thinking the States versus Europe in terms of legislation and how you can get sued and so on. So in that sense, I think Europe in that sense is more maybe pragmatic. You could start in different countries. So I would place my bets on certain countries in Europe.
Yeah, and I think the dialogues that we've had with different OEMs and tier 1s, it also feels like the European scene on safety is, I guess, a little bit more advanced and looking a little bit more ahead. So I would say probably Europe as well would go first.
Per-Olof, do you agree on Europe being first with more autonomous vehicles on the roads?
Well, so what we see here, so Europe and European community is certainly ahead of when it comes to legislation. And next year they come up with a bunch of new sort of rules on ADAS applications, which is good. And normally US and China follow suit. on the one hand. On the other hand, there are way more test beds and launch pads in China than anywhere else for AD and ADAS. And the US infrastructure is the best suited for autonomous driving. So I would pass on who would take the lead here. But I think when it comes to regulation, yes, Europe, definitely.
Yeah, I can agree on that. Europe will be first in the regulations, absolutely. But as you said, China is a fast mover and have also the ability to take decisions in another way than we do in this kind of country like Sweden. So it can go very quick.
And if we take one final question and sort of rewind to sort of a more bird's eye perspective, the first block we had today was in terms of electrification, where we have climate change driving sort of everything forward. If we think about autonomous driving, would you say that the force behind that is that avoiding sort of lethal accidents, or is it efficiency and sort of fewer cars in the market, i.e. climate change again? Or what do you say are the main sort of really big macro factors driving autonomous driving?
My view, as I said before, I think it's very much in this saving life. The 1.3 million people dying every year, and it's small kids up to big and old people. It's a very big number, I would say. You can compare it with things like the pandemic, etc. And then we start to do a lot more. What we do in the automotive industry is that we are slow movers, I would say. So it would be nice to see more actions coming up, because the worst problem is us, the men or women sitting behind the wheel and driving as an idiot.
You have any final words on that before we move forward, Rebecca and Patrick?
Well, I think actually intuitive, I would also say safety, obviously. But just like you said, Per-Olof, disruptive is the key word. Yeah. And we have a generation coming up here that is thinking in different ways. So I think also that there will be other needs that we don't see today that the AD will fulfill, actually, when it comes to different needs in the younger people today that has like another view and perspective on this kind of technology.
And I think that a driving force for AD is that it's going to create a new platform, and on the macro level, there's going to be a lot of money to be made. New platforms, new revenue streams. I think that will also be a massive driving force, especially for the logistics, robot taxis, etc.
And just the final words from me then is that still, if there's no safety, the other parts will not happen. So I guess we're in the game of safety, and that's why I think we believe we are of paramount importance for this business.
Great. And with that, we have to conclude this interesting discussion, and we'll now move directly into our last theme of today. So I welcome Martin Kans from SmartEye.